Alright, here we go, guys. The second part is just more practice with second fundamental theorem, just in different forms. Okay? For what values of x is the graph of f decreasing? Immediately I'm thinking, when is f prime negative? I don't have an f prime, but what we learned today was the second fundamental theorem that I can say f prime is equal to, let's go ahead and go to the integrand, and I have parentheses plus 2, I'm going to use brackets, times parentheses minus 3 brackets squared. And I'm going to do this twice because it's f of b minus f of a. Again, this is the shortcut. And most likely this will be a multiple choice question. Okay, so the shortcut was plug in the upper bound where you have your t's, and then whatever the derivative of that is, multiply that whole thing by that. Then we plug in our lower bound where the t's would lie, and whatever the derivative of that is, which in this case is 0, this would all zero out. You with me? Alright, so what this is going to become is f prime of x is equal to basically x plus 2, x minus 3 squared. See on that last one, the ones that we were doing in the other example, we got g prime of x was f of x, or g double prime was f prime. It doesn't necessarily look like that all the time, even though it is second fundamental theorem. Alright, so I want to know when is this or negative, so I'm going to have to examine the roots. It's nice and factored for us already. The first one is negative 2. This one is 3. Now I'm going to do sign tests. I can say, well, let's try to check out what would the sign be if I plugged in something in this interval, the first one right here. So like negative 3. So negative 3 in this interval, if I plugged it here and here, negative 3 plus 2 is a negative. Negative 3 minus 3 is a negative 6. Squared is always a positive. So this would be a negative product. And if you wanted to use that, what I just said as a shortcut, go for it. This is always going to be a positive. So really, I'm just trying to find the sign of the first factor. So if I plug in 0, it's going to be positive. If I plug in 4, it's going to be a positive. So you will say that this is decreasing from what to what? She says from negative infinity all the way to negative 2 is where this is going to be decreasing. Do we have any other answers out there?
Open parentheses.
Open parentheses on both? Okay, so we could say f decreases on this. What other answers could we show? How about negative 1 to negative 2? You'll see that? So you could say f decreases on negative 1 to negative 2. Yeah?
So like that's like the
Lower bound.
lower bound?
Because remember, you read left to right.
And if it was like flipped, you would like
Okay, so in this respect, I'm glad that you say that. I wouldn't flip it. From what I've said so far in class, when would I only flip it? If I'm looking at a what? graph, right? If I'm analyzing area above or below the x-axis, that's whenever I would actually look at it as flipping it, if needed. How's that? All right. This next one is going to be big time conceptual. Here we go. What is f of x? Is this f of x? No. What could I do to make that's in the blue box become f of x? Second fundamental theorem. I could take the derivative. If I take the derivative of the right side, it becomes a positive f of x. Technically minus 0, because c is a constant. Therefore, 6x is the derivative. So f of x is 6x. How could I find the value of c? If this is the position function, couldn't I also say that f prime is what? 6. You with me? And for the sake of just understanding, I'll keep it as that for now. Okay, there's more to it. I'm just not going to show it after all because it's not tested in that way, unless you have a question. Do you have a question?
I don't.
Okay.
So we're not to know how to find the value of c?
No. I just wanted to make sure that you understood what you were looking for and what pieces kind of match up with what. Okay? Alright, so let's go to, that's what I was just talking to Mr. O'Brien about, whether or not this is tested. Let's go to, I believe that's it, guys. That's it, second fundamental theorem wise. Let me see if I can find one. Okay, here we go. So f prime is cosine of x squared. Now that we know first fundamental theorem and second fundamental theorem, we should be able to find problems like this and understand how to solve them out, okay? My goal is to find f of 3 from these two pieces that are given. Any ideas? Integrate what?
F prime.
F prime. Perfect. We're going to integrate f prime. Right? What does this look like? It looks like first fundamental theorem. Because if I do this, isn't it this right here? Okay. What's A? 2. What's B? 3. What are we looking for? F of 3. Do we know what f of 2 is? What is it? 7. So I'm going to replace f of 2 as the y value of 7. So if I wanted f of 3, all I need to do is add this 7 over And it's basically going to analyze that. If I can find out what all of this equals, that is f of 3. And we will start to learn that next time with u substitution and whatnot. But our setup was still using first fundamental theorem of calculus. And that's all I have.